Hey, welcome back. In this episode, we're going to look into how can you design for databases, and within that, we're going to learn about how can you select an appropriate data platform based on requirements. Recommending the right data source for your requirements is a key design decision. There are hundreds of implementations to choose among SQL and NoSQL databases. Data stores are often categorized by how they structure data and the types of operations they support. Note that the data store technology may support multiple storage models. For example, the relational database management systems, which is RDBMS, may also support key value or graph storage. In fact, there is a general trend for so-called multi-model support, where a single database system supports several models. But it's still useful to understand the different models at a high level. So in this lesson, I'm going to explain a few of these components: RDBMS, key value stores, document database, graph databases, and data analytics. First, let's understand what is relational database management system. Relational databases organize data as a series of two-dimensional tables with rows and columns. Each table has its own columns, and every row in a table has the same set of columns. This model is mathematically based, and most vendors provide a dialect of the structured query language for retrieving and managing data. An RDBMS typically implements a transactionally consistent mechanism that conforms to the asset, which is known as atomic, consistent, isolated, durable model for updating information. An RDBMS typically supports a schema on write model, where the data structure is defined ahead of time and all read or write operations must use the schema. This is in contrast to most NoSQL data sources, particularly key value types, where the schema on read model assumes that the client will be imposing its own imperative schema on data coming out of the database and is agnostic to the data format being written. And RDBMS is very useful when strong consistency guarantees are important and where all changes are atomic and transactions always leave the data in a consistent state. Some of the relevant Azure services for RDBMS are Azure SQL Database and Azure Database for MySQL. Now let's look into key value stores. A key value store is a large hash table. You associate each data value with a unique key, and the key value store uses this key to store the data by using an appropriate hash function. The hashing function is selected to provide an even distribution of hashed keys across the data store. Most key value stores only support simple query, insert, and delete operations. To modify a value, either partially or completely, an application must override the existing data for the entire value. In most implementations, reading or writing a single value is an atomic operation. If the value is large, writing may take some time. An application can store arbitrary data as a set of values, although some key value stores impose limits on maximum size of values. The stored values are opaque to the storage system software. Any schema information must be provided and interrupted by the application. Essentially, values are blobs, and key value store simply retrieves or stores the value by key. Some of the relevant Azure services for key value stores are Azure Cosmos DB, Azure Cache for Redis, and Azure Tables. Now let's look into document databases. A document database is conceptually similar to key value store, except that it stores a collection of named fields and data, each of which could be a simple scalar items or compound elements such as list and child collections. The data in the field of a document can be encoded in a variety of ways, including XML, YAML, JSON, and BASIN, or even stored as plain text as well. Unlike key value stores, the fields in documents are exposed to the storage management system, enabling an application to query and filter data by using the values in these fields. A document store does not require that all documents have the same structure. This free-form approach provides a great deal of flexibility. Applications can store different data in documents as business requirement changes. One of the common Azure service which uses document database structure is Azure Cosmos DB. Now let's look into graph databases. A graph database stores two types of information: nodes and edges. You can think of nodes as entities and edges are which is simplify the relationship between nodes. Both nodes and edges can have properties that provide information about that node or edge, similar to columns in a table. And edges can also have a direction indicating the nature of the relationship. The purpose of a graph database is to allow an application to effectively perform queries that traverse the network of nodes and edges and to analyze the relationship between entities. This is an example diagram which shows an organizational personal database structure as a graph. The entities are employees and departments, and edges indicate reporting relationship and department in which employees work. In this graph, the arrows on the edges show the direction of these relationships. And the relevant Azure service which can use the graph database is Azure Cosmos DB. That concludes this episode. In the next video, we're going to learn about the overview of Azure Data Storage. I will see you on the next one. Until then, take care.